Today I want to look at the limit comparison test. Now, the limit comparison test says that if we have some summation a sub n, right? And then we have another summation of which we already know some information about, we'll call b sub n, right? So when I say we know some information, I mean that we know if b sub n converges or diverges, right? And again, we want to use b sub n to figure out something about a sub n. So let's say we have these two series, right? A sub n is the one we're trying to figure some stuff about, right? If the limit as n approaches infinity of a sub n over b sub n is equal to something positive, we'll say, and finite, so positive and finite, then both series will either converge or diverge, right? And that might seem pretty useless because we're trying to figure out if it converges or diverges. But remember, we already know if b sub n converges or diverges. Therefore, if our limit over here becomes something that is positive or finite, then whatever is true about b sub n will be true about a sub n. So let's look at an example to kind of illustrate this, right? Say we want to tell if the sum from n equals 1 to infinity of 1 over n plus 1, if that converges or diverges, right? Now, there's something we can compare this to, right? We can compare this to the harmonic series. Now, if you don't remember the harmonic series is the sum as from n equals 1 to infinity of 1 over n. And the harmonic series, we know, diverges, right? So this diverges. So since this is something we know some information about, and it's pretty similar to our other series, 1 over n plus 1, we can use this for our limit comparison test. Now, before we do that, something to note is, why aren't we just using the direct comparison test, right? Well, the answer to that is clear. So 1 over n plus 1 is a smaller series than 1 over n because the n plus 1 in our denominator means that we'll have a larger denominator than n, right? Say when n is equal to 4, n plus 1 is obviously equal to 5, and 1/5 is less than 1/4. So 1 over n plus 1 is always going to be less than 1 over n. And by our direct comparison test, knowing that 1 over n diverges doesn't really tell us anything about 1 over n plus 1. If 1 over n converged, then we would know that our smaller series also converges, but that's not the case. So this is why we're going to do our limit comparison test. So let's take the limit, right? Let's do this right over here. We'll do a different color. Let's say this one. We're going to do the limit as n approaches infinity of our a sub n in this case is going to be 1 over n plus 1 because that's the one we don't know anything about. So 1 over n plus 1. Limit as n approaches infinity of 1 over n plus 1 all over b sub n, which is going to be 1 over n, right? Now, instead of dividing by fractions, we can simplify this, and we could say the limit as n approaches infinity of 1 over n plus 1 times n plus 1, n over 1, sorry, excuse me for that. So this is going to be n over n plus 1, so there we go. And now, since we're taking our limit, we know limits at this point, come on. If we're at series, we can do our limits. And as approaching infinity, our numerator and denominator both have the same degree, right? They both go, those look like 0, so I'll erase that. But our n's are both to the first power, right? So we can just divide n by n, and we'll get that this is equal to 1. Now, last I checked, 1 is both positive and finite. So we know that both of our series either converge or diverge. But we know that our harmonic series over here, 1 over n, diverges, which tells us that a sub n also diverges. So if you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.